When you got billions of dollars invested in a fab, it's important to keep it running. The more the light stays green, the more your business is in the black. Service isn't just necessary, it's critical, which is why Applied Materials is reinventing it. Take Expert Connect, 7x24 remote service capability that speeds resolution of problems. It brings the full resources of Applied Materials into your fab. Imagine, you run a fab in Japan. One of your 300mm constraint tools is down hard. Your team is troubleshooting, but the whip is stacking up, and it's getting worse by the minute. Can you get the help you need? When will it arrive? And how much is it going to cost before you get it solved? Sound familiar? With Applied Performance-Based Service, the scenario's a lot different. Now you have Expert Connect working for you. Your local Applied team engages. It's an unusual issue, so they escalate it to additional resources outside the area. Quickly, an entire network is on the case. No waiting for someone to fly in. A product expert working remotely is now supporting the local team. He uses Applied's proprietary diagnostics technology to view and navigate the computer on the down tool. He communicates in real time with the local team, and if necessary, can engage other product experts from around the globe to solve the problem. Using Applied's Tool Set Manager, he mines and transforms the raw data of the logs into a graphical format so he can identify the clues and markers faster than they can on site. He accesses our best practices network, 4 decades of collective tool maintenance expertise. And with Applied's Nexus eDiagnostics package, he analyzes tool sensor data to rapidly identify root cause and initiate a solution. It's the fastest service response time in the business, period. Mean time to repair is shorter, and you're not blindly replacing parts in hopes of a fix, so costs are lower too. And Expert Connect is completely secure. Customers maintain total control of their proprietary data, and all we look at is what's failed, why, and whether it's been fixed. But that's just the half of it. We're not just fixing downs, we're taking the time to understand the characteristics of failures so we can recognize, predict, and prevent them. So as the product expert identifies the cause of the down in Japan, he is able to resolve the problem, and he makes the tool smarter, building predictability against similar events in the future. Tools stay in the green longer, producing more wafers, which means more revenue-generating product out the door. So when you add Expert Connect to the other elements of performance-based service, like the best practices network, continuous improvement programs, and end-to-end support services, what you have is a whole new model for service, one that transforms it from an expense into a competitive advantage. Performance-based service from Applied Materials. Re-engineering service from the chamber to the bottom line.
Good afternoon. Wanted to show you that video that a couple of folks suggested we play for you folks to give you an idea of what's going on in the semiconductor world before I gave my presentation from IBM. Applied Materials, of course, is one of our suppliers, as well as ILS Technologies, and some of that technology you saw referenced there is a product of both of those two companies. So I wanted to open up with that, and then give you a little idea of what we're doing in the semiconductor business and why remote operation and remote diagnostics is important to us, and in particular why and how we chose a vendor-neutral secure solution for this application. So I wanted to start with a little bit of an overview of the 300mm facility in East Fishkill, New York, talk to you about our criteria for selecting the right remote access solution, give a couple of examples, and talk about some lessons learned. And then we'll save the questions, I guess, until the end when we have the panel discussion. So the reason that we exist as part of the IBM Corporation is to provide our systems team with leading industry technology. So our goal is to always give the systems group the technology they need to be on the leading edge of server development. We also have to make it pay for itself. So we leverage our external business partners for scale to pull all this together. So in order to serve these needs, we're always fighting this, this curve here, where you see that over time, when technology is at its highest value and concept phase and drops over time to commodity, the manufacturability increases. And we're always looking to see how to tackle pushing that curve higher and higher, and in order to provide this value to our customers, both internal and external. What's happened as we've gotten better at this over the years, since we built the 300 millimeter facility in the early 2000s, was our dynamic has changed. And the way we see part of that change is in a collaborative approach to bringing technology to market. Originally, we had our research team, and then we did our development in-house and our manufacturing in-house. And what's changed is we've linked all these components together so that we have fundamental research where we're screening new materials and new processes, tied very closely to a consortium type of an environment at SUNY Albany, the nanotech facility there in Albany, New York. This is where we have not only IBM and the university and various partners working together, but also our equipment suppliers come together so that they're working with us on the leading edge technology development roadmap so that they can deliver equipment that meets our needs as we develop the technologies in our factories. That technology then makes its way to the Fishkill facility, where we have multiple partners there working in different areas. And the key to note here is that different partners have access to different levels of technology. So IP protection is very important to us in the factory. So as we talk about providing more and more access to the factory and to the data and to the information in the factory, we have to keep working on security and IP security as we move that forward. And then to complete the picture, we have a worldwide manufacturing arrangement with other companies that are partners of ours as well. So we have moved from a standalone solution space to a very innovative and collaborative environment in which we work. So what we ended up with as we built this facility and really got it into this mode that we're talking about is a world-class combined development and manufacturing facility in the same location, providing these leading edge technologies to ourselves and our partners. It's a 300 millimeter wafer facility, as I mentioned, and it has a capacity of about 400 to 500 wafer starts a day. We also hope that you get that many out at the end of the day as well, otherwise you've lost a bunch of wafers in the middle. But that really depends on the technology mix. And we've qualified technology nodes all the way from the early days, the old stuff, down to bulk manufacturing today at 45 nanometer ground rules. 32 nanometer is well on its way, and 22 nanometer wafers are flowing back and forth between Albany and our factory as well as we speak today. The facility is extremely expensive. In terms of just the size of the building, it's not that big. This is not a really big facility, but the investment in the equipment is quite staggering. This has gone up over the years, and that's probably more like a 6 now, and that number there. And that's mostly driven by the equipment costs. As I said, it's not that big. It's only about 140,000 square feet of the main space, plus then we added an annex of about 72,000 square feet. And it would have I think now we're closer to 650 pieces of equipment in the factory and adding to it as we speak. This is a diagram of roughly what that looks like. We originally started out with manufacturing and development co-located in the same building as we embarked on this new paradigm of co-located manufacturing and development to attack that curve. And then we added the annex on, where we have now opened this side up as well and are populating it with tools as we speak. Our main goal as we put this facility in place is to keep it running 364 days out of the year, 24/7. We had one day down last year over Christmas Day for a software upgrade in the factory, but otherwise the facility must run. And we must do everything we can to keep it running as efficiently as possible. Part of the solution that we put in place was to look for an e-diagnostics solution that would help us take advantage of a worldwide support infrastructure to keep the equipment up and running as much as possible. We decided early on that from a scope perspective that the solution had to follow guidelines from the industries, the standards from Semitech and SEMI, and follow those guidelines. Simple things at this level like access and remote collaboration, which would be remote connectivity to the tool, and then the collaboration capabilities, and collection and control. So this would be remote tool operation and performance monitoring. Added to that, we had to make sure that we had a secure VPN connection between IBM and any of the OEM suppliers out there who we were going to give access to the facility. There had to be no adverse effect on the operation of the equipment. When you RTO into a tool, when you go in for remote tool takeover, you don't want to slow the tool down because you've mounted that tool. So we have to make sure that our support systems get the most out of the equipment without sacrifice. Of course, it has to meet our ever-changing and constantly evolving security standards. As you know, if you have anything but an Apple laptop, you have to do Microsoft updates all the time. Well, there are real reasons for that. There's things changing out there all the time from a security perspective, and that goes as well inside a factory like this. So security is always changing. And one of the other things that we wanted to make sure is we were in control of access levels. So down to the file in a folder on a tool, we determine who has the right access to get to that information and how they get there. So those were some of the requirements up front. We went to Semitech way back in the early 2000s where they were trying to define what this solution was going to look like. And they have a definition up here at the top you can read. It was mainly built around the idea that you would have suppliers at their various sites around the world going through a secure tunnel through an access control point into various factories to provide remote access and support and data flow back and forth. And that was pretty much it. It was to repair the equipment when you needed to and get the equipment back up and running in a safe and secure manner. So what we looked at was putting in place a commercial solution that was vendor neutral. When we first looked at this, there were equipment suppliers who had their own e-diagnostics type solutions, but that would only work on their equipment. And that's not what we wanted. We needed a solution that worked across the factory, across all 600 tools, and was agnostic as to who the supplier of that particular tool was. We are not the experts at putting a solution like that in place, the chip manufacturers. That's why we looked outside to the other areas in the industry. And what we found was for us to be the lowest cost approach, working with ILS, where our upfront costs were shared by both IBM and our OEM suppliers, and it meets all the security guidelines and security standards. So that was very important to us as we chose a solution to put in place.